Let us take one more problem. Let us solve this quickly. Will not take as much time that we had taken to solve the first problem because it was the very first problem for you all. I was going very slow with it, but this time I'm going to skip a lot of steps also, and we are going to do it quickly just to understand the problem. And I'm not going to do it in the standard way. In HC, when you're solving the problem, you are expected to solve it the way I had done in the previous video. So you have to solve the problem in that way only. Right now, what I'm going to do is I'm going to quickly solve the problem by skipping some steps, which is not advisable to do in HC. In HSC, you have to solve the problem like I had solved in the previous video. Again and again, I'm saying this. In HSC, you'll have to do it stepwise. Step 1, 2, 3, 4. Stepwise, you'll have to solve the problem. Okay. But here, I'm going to skip some steps to quickly get the answer. So, construction company uses concrete blocks made up of cement and sand. Weight of concrete block has to be at least 5 kg. Cement cost is rupees 20 per kg, while sand is costing rupees 6 per kg. Strength considerations dictate that concrete block should contain at least minimum of 4 kg of cement and not more than 2 kg of sand. Form the LPP for the cost to be minimum. So the problem is about only forming the LPP, but I'm going to form and also solve. Okay. So let us first form the LPP. Now tell me what is the important part here is we have to minimize the cost. Form the LPP for the cost to be minimum. So now the second thought in your mind should be running is what does cost depend on? So cost depend on the cost of cement. Cement is rupees 20 per kg while sand is rupees 6 per kg. So cost depends on the cost of cement and the cost of sand. That is the cost of components which we are going to use to make the concrete blocks. Okay. So what will be our decision making variables? Cement and sand. So let X kgs of cement and Y kgs of sand be used. Okay. Now the total weight of the concrete block, has to be at least 5 kg. Obviously weight depends on these two components, that is the weight of the cement, the weight of the sand, we say. So therefore X plus Y has to be at least 5 kgs. Okay. X plus Y has to be 5 kgs. Minimum the value of the block or the weight of the block has to be 5 kgs. Has to be at least 5 kgs. It has to be more than that. Right? Strength considerations. Now we come to strength considerations. I'm skipping the step. I'm not writing that the total weight of the block must be greater than 5. So therefore it comes in the numerical format as X plus Y greater than or equal to 5. I'm not writing all that. Okay. I'm leaving up to you. Next is strength considerations dictate that the concrete block should be minimum 4 kg. The concrete block should be having minimum 4 kg cement. So that gives rise to the next constraint, that is X has to be minimum of 4. X has to be minimum of 4 and not more than 2 kgs of sand. So and Y has to be less than or equal to 2. It can't be exceeding 2. I'm not writing the steps. I'm not writing all the steps. You need to explain all this while doing a problem in HSC. I'm just directly writing the numerical form. So X plus Y is greater than or equal to 5. The minimum weight of the block should be 5 kgs. Minimum cement used should be 4 kgs. Maximum sand used should be 2 kgs. Okay. What will be the total cost? Minimize cost, that is Z equal to. Now what is the cost? Cost of making blocks or concrete blocks depends on the cost of cement and depends on the cost of sand. So cement cost is 20 per kg. So here we are using x kgs of cement. So we have 20x. For sand per kg, the cost is 6 rupees. So we are going to get 6y. For sand, the cost is 6 rupees. For cement, the cost is 20 rupees. So 20x plus 6y is the total cost for making the concrete blocks, and we are going to minimize it. So in short, I have written down the LPP. Okay. One thing is remaining here is x is greater than 4 means x is positive. So उसके लिए non-negativity constraints are not needed. But here when I say y is less than 2, it does not mean that y can be negative. So we have to say y has to be greater than or equal to 0. X also has to be greater than or equal to 0, but x greater than or equal to 0 is redundant because x is already greater than 4. I repeat the word, x greater than or equal to 0 is redundant constraint. It is of no use to us, but it is considered as non-negativity constraint. It is there because your amount of cement used can't be negative. It has to be greater than or equal to 0. But already we have greater than or equal to 4, x greater than or equal to 4. So it won't be of much use to us. But it is there. It is there and it won't be of use to us. Therefore, it is a redundant constraint. Already x is greater than 4. That means it is greater than 0. But in the sand constraint, it is needed. It is very much needed. You can't take negative values which are less than 2. You have to say y is less than 2 but still greater than 0. X is also greater than 0. Y is also greater than 0. They are non-negativity constraints. X greater than 0 will not be useful since x is already greater than 4. But for y, it has to be between 0 and 2. Okay. So that is the problem. I'm going to write down the problem again. So your problem can also start like this. You might not get the word problem, but they might give you the problem like this. Minimize z is equals to 20x plus 6y. Okay. Minimize z equal to 20x plus 6y. Subject to x plus y greater than or equal to 5, x greater than or equal to 4, y is greater than or equal to 0 but less than or equal to 2. Okay, I'm straight away making the graph. Step 1, step 2, step 3 नहीं कर रहा हूँ मैं, step 4 नहीं कर रहा हूँ. That is how it is expected in HSC. But I'm straight away making the graph. So word problem is done. Now we are going to do the graph. Okay, x-axis y is equal to 0, y-axis. This is how you will be solving in CET if the problem comes. And first inequation is x plus y equal to 5. Straight line is x plus y equal to 5, right? X plus y equal to 5. In that, the first intercept is 5, 0. The second intercept is also 5, and we can say it is 0, 5. That is equation 1. In equation 1, and the solution is coming as, if you put origin to check, you put x as 0, you put y as 0, you get 0 greater than 5. 0 greater than 5 is false. 0 can't be greater than 5, it is less than 5. So 0 greater than 5 is false. And therefore, we say the solution is non-origin side. I'm not writing all that. I'm not writing step 1, 2, 3, 4. That is how it is expected in HSC. In CET, you can do it like this. Form the inequations and start directly with the graph. Next says x has to be minimum 4. Next inequation says x has to be greater than or equal to 4. So the corresponding line is x equal to 4. The corresponding line is x equal to 4, which is going to be a vertical line. X equal to 4 is a vertical line passing through 4 comma 0 perpendicular to x-axis. Passing through 4 comma 0 perpendicular to x-axis. A is 5 comma 0 and this is x equal to 4 line. Okay. What about the solution? It has to be greater than 4. Greater than 4 is this side. Greater than 5. Greater than 4. Okay. What is the point of intersection of x equal to 4 and x plus y equal to 5? The point of intersection is this point here. Right, we can call that point as P. P is 4 comma 1. Okay, P is 4 comma 1. So next will be y equal to 2 line. It will be perpendicular to y-axis, but passing, it is going to pass above 4 comma 1, from above 4 comma 1, right? 4 comma 1, this is going to be the point Q, which is 4 comma 2. 4 comma 1, 4 comma 2, y equal to 2, perpendicular to y-axis, x equal to 4, perpendicular to x-axis, 4 comma 2, 4 comma 1. Okay, first quadrant. It has to be first quadrant. Again, non-origin side for x plus y greater than 5, non-origin side, x greater than 4, but between 0 and 2. So I would say this is the feasible region. Okay, that is the feasible region. It is feasible region which can go till infinity. But we don't have to worry about it because we don't have to maximize, we have to minimize. Minimum value चाहिए. अगर maximum value चाहिए तो वो नहीं मिलेगा. It will be going till infinity. So you can't calculate the maximum value. It is unbounded feasible region. It's not like quadrilateral in the previous sum. It's not triangle. It's unbounded feasible region. We can say this is unbounded feasible region. On unbounded feasible region, you can't maximize because you don't know what is the last point, last corner point in the feasible region. So we can't maximize, but we can have problems on minimizing the objective function in this unbounded feasible region. So for this, I'm straight away writing the optimization table. Corner points पता चल गया है, APQ है. So I'm straight away writing the values of the objective function ZQ. You can say ZQ is 20x plus 6y. So we are going to get 20 into 4 plus 6 into 2. 80 plus 12. 80 plus 12. That is 92. The cost will be 90 rupees if I'm going with the coordinates of Q. If I'm taking 4 kgs of cement and 2 kgs of sand, it is going to be 92 rupees for the block. Okay. If I am taking point P, ZP, I'm going to get 20 into 4 plus 6 into 1, 86 rupees. If I'm taking A, okay, if I'm taking A, ZA is going to be, if I'm taking A, it is 5 comma 0 for A, so 5 comma 0. If I'm taking that and I'm putting in the objective function, it is 20 into 5 plus 6 into 0. It is 100 rupees. Okay, so where is the minimum value occurring at which corner point? Definitely at point P. So minimum value at P, P is 4 comma 1. What is the minimum rupees or the cost occurring here is minimum cost is going to be at P4 comma 1. What is that minimum cost? 86 rupees. At Q it is 92. At A it is 100. It is an unbounded feasible region. 3 corner points for the minimum value we have, and the minimum value is at P 86 rupees. That means you will have to use 4 kgs, minimum 4 kgs of cement and 1 kg of sand to make the blocks. I hope you have understood the problem. Again, let us revise the problem quickly. So the problem started from here. We had construction company using making concrete blocks made up of cement and sand. Weight of concrete block has to be 5 kg. So that gives rise to this constraint. X plus y has to be 5. What is x? It is kgs of cement used. What is y? It is kgs of sand used. So x plus y has to be minimum 5. In that, cement has to be minimum 4. It has to be greater than 4. And sand has to be maximum 2 kgs. Okay, what we are going to do is we are going to minimize the cost. Cement cost is 20 per kg. So total cost of cement used is total cement used is 20x, while sand used is 6y. So we get 20x plus 6y as the total amount spent. It depends on the cement and the sand again, and that has to be minimized. So total cost is minimized. It is 20x plus 6y has to be minimized. So that is the formation of LPP. I'm doing it in short only for CET questions. And the next, I'm not solving it using step 1, step 2, step 3, step 4 process, which I had shown you in the previous video. We are straight away going to the graph, and the graph has the first constraint x plus y greater than or equal to 5. X plus y equal to 5. This is a straight line. Okay, and this is the solution, non-origin side. Then we have second constraint x greater than or equal to 4, non-origin side, y between 0 and 2. And this is the feasible region. We have unbounded feasible region. You can't maximize in this feasible region, but we have to minimize, so not a problem. Minimum value will be occurring at the corner points only. You can check any point you can take from the feasible region, but the minimum or the maximum value will always occur at the corner points. So A is 5, 0. We took the objective function value 20x plus 6y, 20x plus 6y with the coordinates here 100. Objective function values at P 86. Objective function values at Q 92. So 92, 86, 100. Minimum value is 86. 20x plus 6y I have calculated for all the coordinates, and minimum is at point P. It is not 100 rupees, sorry, it is 86 rupees. Minimum value is 86 rupees. When x is 4, y is 1. 4 kgs of cement, 1 kg of sand. Okay, so now you can solve the problems like this in CET. Just get the constraints out, make the graph straight away, and in the graph only you find the minimum value or the maximum value, whatever they have asked. In HSC, you will have to do stepwise, step 1, 2, 3, 4, like I had shown in the previous video. Okay.